Okay. Hello, everyone. The attendees are coming in. We are in the waiting time for a few seconds, and we will start the second session. So the live session, the first live session, go hopefully well. I think they may have some people that are joining now, step by step. And we are going to start in a few seconds. So we have a tick schedule, so I hope that everybody will join rapidly, jumping in the session for the second plenary session. So let's wait for, let's say, a tenth of a second, and we will start soon. And we will have these two parts with a Q&A session at the middle. So I think we can go live, I think. Okay, so we are going to start the second session, the second plenary session with a focus on co-design and on implementation. We will have two presentations, one coming from Raphaelle, Barbier and Pascal Lemasson that will be soon displayed, and then a presentation by Marie-Françoise Voidrot. So the process will be the following. We will have first the presentation, and there will be after each presentation a Q&A, question and answer session of a few minutes. So if you have any question, please use the chat. We will ask to all the questions, so you can type your different message during the presentation in order we can have all of them, and one by one we will try to have the feedback for the presenter and have the potential answer they can provide you on the different work they are going to present. Sorry. So I think now we can go on with the first presentation, which is done through a video. And so if you are okay, yeah, you can run the video and go on. Thank you.
Good morning. I'm Raphaelle Barbier, and with this session, I will investigate with you the following topic in the perspective of developing services from Earth observation data for and with users, how co-design can grow an ecosystem of efficient service designers. So I will start by introducing the context, then we'll go a bit more deeply in the questions that are behind co-design in the Earth observation context. Then I'll present to you the first results we have from this first year of experimentation within eShape. And finally, I'll give you some conclusion and perspectives for the future. So let's start with the context. So in the Earth observation community, the question that is currently at stake is the development of socioeconomic applications to Earth observation data, and especially how to accelerate the growth of the ecosystem. So there was a first approach that has been pushed in the last few years, that is an open data approach that aims at providing full, free and open access to data. And well, it proved to be, of course, necessary, but not sufficient, as outside the scientific community, it was still hard to encourage people to take advantage of this data spontaneously. So recently, another type of approach has been encouraged in eShape and also in other European projects, that is going beyond the sole open data approach and to co-design services to further support the development of these services. So in eShape, there is a specific work package that is dedicated to designing and experimenting a co-design approach that is adapted to the Earth observation context. And this work package is supported by our research organization, so the Center for Management Sciences at Paristech, PSL University in France, which is specialized in design theory and methods for innovation. So this is our team, Raphaelle Barbier, PhD student, and I'm also working with Skander Benyaha, intern, Pascal Lemasson and Benoît Veil, both professors at Paristech, and also Louis-Étienne Dubois, working at Toronto. So if we go into the problem of co-design in the Earth observation context. So the questions are how co-design could support the development of EO-based services, and actually what co-design are we talking about? So let's have a look at what the literature tells us. So in literature, when you hear about co-design, you probably have in mind this first type of situation where there is a misfit between solutions developed and user needs. And in this case, co-design refers to a method that involves the end user to fit the solutions to user needs. So this is a first type of situation that has largely developed since the years 2000s, where the blocking point is related to the interaction between the user and the service designer. However, if you look at the history of co-design, you can notice that it was also used in completely different situations that we tend to forget. So in the 80s, in the automotive industry, there was a need of designing new modules for better comfort and emission reduction. And this required to reshape the collaboration between OEM and suppliers to co-design these new modules rather than just negotiating over prices. But actually, co-design was born even before, in the 70s, for the development of embedded systems. So here, the list of requirements of the embedded systems was well established, but the issue was to make different fields of expertise cooperate, mechanics, electronics, especially for hardware and software integration. So if we summarize, here the issues to be addressed are actually to grow an ecosystem of designers, and the blocking points are not only at the end user's level, but rather in the service designer's ecosystem. And here the co-design method refers to building new types of relationships with the stakeholders of the ecosystem to build innovative services. So if we summarize what can be learned from literature, we see that co-design refers to a much larger variety of situations than what we usually have in mind. And it initially actually emerged in the engineering design field with issues that are a bit different from the only relationship between user and service designer. So we can now reformulate the ambition of co-design, thanks to this little historical study, as follows. So co-design has the objective to grow an ecosystem of efficient designers by handling different blocking points that do not only occur in the relationship between the user and service designer. So now, what about the Earth observation context? So the problem that we encounter in the Earth observation context could be described as a distant relationship between data and value of this data or usages. Indeed, if you start from the end user's point of view, for example, someone wanting to improve the logistics for tire change, then it's hard to see how it could be, how EO data could be useful. And on the other way around, if you start with the data provider, you might have some existing usages But then the question is, how do you make these usages evolve over time? And behind this distant relationship, there is actually a high heterogeneity of actors with two complex ecosystems, both on the user side and also on the service providers side. So in this case, we are still in a situation where the issues to be addressed are growing an ecosystem of designers, of service designers, but and blocking points in this case not only do not only occur at the end users level again, but compared to the situation of the 70s and the 80s, the Earth observation context is quite specific, especially on the users' ecosystem, which is quite complex, with not only end users, but also lots of possible intermediary users. And in addition to that, you can have some propagation effects to the service provider's ecosystem. That means that a change in the user's ecosystem can have large impact on the service provider's ecosystem. So because of these specificities, there is a need to design a specific co-design method that is adapted to this context. And that's what we are doing in eShape. So if I summarize the issue that is related to co-design and that we need to address in eShape, I'd like to make a little comparison between co-design activities and gardening activities. So in gardening activities, so you have a plant that grows organically, but that might face some issues during its growth phase. And the gardener is here to take care of the plant, to allow the plant to keep growing. And actually, it's quite similar to the situation of co-design that aims at growing an ecosystem of efficient service designers. So the service designers already grow by themselves, but they might face some issues during their growth phase. And co-design actions, as the gardener, has to help the service designers to overcome these issues and allow the ecosystem to keep growing. So now that the stakes are clear, we can precise our research questions as follows. So the first question is, what are the blocking points in the growth of the ecosystem? And here there are two sub-questions. So first, how we identify these blocking points. And second, what are the blocking points that we can identify on the eShape pilots? And well, the second big question is then, once we have identified the blocking points, how we can unlock them. So after this first year of eShape, we are now able to give some first insights on these questions. So regarding the first question, we have put in place a specific diagnostic toolkit to identify blocking points that includes a specific process and different tools. So the first tool is the representation of each pilot's ecosystem, and the second one is the representation of blocking points through a certain classification. So if I zoom in the first tool, so this is a framework that represents each pilot as a relationship linking data, information, and usages for a certain user community. And in eShape, all pilots are starting with some users, so we can say that there is an existing pipe going from data to usages. And the objective of eShape is then to extend this existing pipe, possibly on all the different elements of the chain. So thanks to this framework, you can spot the blocking elements on the chain, starting with the one that is located at the interaction between the pilot and the users. And for this specific blocking point, we can consider that it is blocking if the usefulness and usability of the service is not clearly established, or if the relationship between the pilot and the user is not robust. And if there is a blocking point at this level, you also have to analyze the other blocking points that can be related and that can be located elsewhere on the on this chain. So that's where the second tool comes into play. So the second tool is a classification of the blocking points that we also call co-design needs in 4 main types based on the status of the usefulness and usability of the service and the status of the relationship between the service designer and the user. So this is the classification of the co-design needs that I will illustrate on some examples from eShape pilots. So the first type of co-design need is actually quite similar to what we usually have in mind regarding co-design. So this is a situation where the usefulness of the service or the relationship is not clearly established, but there is a favorable relationship. And the objective is here to further clarify the list of requirements and also establish the relationship between the service provider and the user. So this is the example. This is the case for a pilot that aims at building a health surveillance and air quality platform for Athens and other Greek stakeholders. So the pilot has already initiated some interactions with a pool of actors, going from national authorities to cities, other networks, and the private sector. But the usefulness of the service and the relationship with these different actors are not completely clear. So the objective here is to enrich the range of the list of requirements and also establish the future partnerships accordingly. Second situation is a case where usefulness or relationship are not clearly established yet, again, but there is a problematic relationship with the user. It means that either the user proves to be not committed, or if it proves to be not relevant for the service purposes. So this is, for example, the case for a pilot that aims at building wind resource assessment products and services for the offshore wind industry. So the pilot has already initiated, has already had in the past on-the-spot interactions with the different actors of the ecosystem, but there is a problem to build long-term relationships with them. So here the issue is to make a systematic exploration of potential committed users and to build a minimum usefulness of the service for these users. Third type of situation is the case where usefulness and relationship are clearly established, and there are still efforts to be made to build an operational service. So this is, for example, the case for a pilot that aims at building surface solar irradiance nowcast and forecast services at urban scale. So here there is no problem with the user, so in Sun we trust. So the usefulness and the relationship with the user is established. But to make the service operational, there are still actions to be made. And here it is especially important that the research lab establishes a specific partnership with a commercial entity that would be in charge of the engineering and commercialization of the service. Okay, so Third, this was the first situation. Now, fourth type of situation, still in a case where usefulness and relationship are already clearly established. But the issue is how we can develop future usages in a long-term perspective. So this is the case for a pilot that aims at building services for monitoring and management of sargassum influx. So sargassum is a type of algae that invades beaches, especially in the Caribbean region. And there are already operational services, mainly for monitoring purposes. But the objective of the pilot is here to stimulate the emergence of new actors or new operations to tackle sargassum issue that can be stimulate the emergence of the algae valorization chain, for example. And here the objective is then to build a kind of long-term agenda between several actors of the ecosystem to explore these new usages. Okay, so this was the diagnostic toolkit. In a way, a kind of microscope that we have built to identify the different blocking points of the ecosystem. So now the question is to see what we can observe in this microscope. So we have completed the diagnosis phase for 21 pilots in E-shape. And thanks to that, we can try to draw some first conclusions. So if we look at the different types that concern the different pilots, we can first see that actually the type 1 concerns almost every pilot. Well, this is not very surprising because it comes from how E-shape was built with at least one user involved per pilot. And it also confirms the fact that indeed the interaction between the service designer and the user remains a crucial point of attention. Well, the second result is less evident. So we see that even at short term, type 1 usually is not alone. So there are other types coming with type 1. So there are several reasons that can explain this fact. The first one is that per pilot, there might be several users with different status of relationships that are, so they can be more or less recent. And second reason is that in some cases, the type 1 is a way of testing the interaction with the user, and it can reveal quickly other blocking points, making the pilot evolve rapidly towards type 2 if the relationship proves to be problematic, or type 3 if the relationship is strengthened rapidly. And finally, there is a third result, this time considering the long-term perspective, and we can see that future blocking points can be anticipated. So it confirms again the fact that type 1 is not sufficient on a long-term perspective and needs to be complemented by other types of actions. So now that we have identified the types of blocking points that could hinder the growth of the ecosystem, the question is how to unlock them. And in addition to the diagnostic toolkit, then there is a need of building an action toolkit to unlock the different blocking points. And there is especially one action toolkit that needs to be built for each type of co-design action. So this is still under experimentation for types 2, 3, and 4. So in this presentation, I will mainly illustrate co-design action toolkits on the type 1. And I will especially give some examples of the experimentation we had with the pilot related to health surveillance and air quality in Athens. So first, co-design action toolkit is built to reach a certain objective. So in the type 1, the objective was twofold. First, the assessing and enhancing the list of requirements of the service for the users. And second, setting up the future relationships with the users. Well, in addition to this overall objective, the co-design action toolkit also relies on a certain principle that is to favor a resilient fit type of action rather than a quick fit action. So what do I mean by that exactly? Well, this is a distinction that is inspired by design theory. So a quick fit can be described as only focusing on one user and one specific list of requirements, whereas resilient fit can be described as exploring a range of lists of requirements and a range of possible cooperation modalities. And this is actually a way of better adapting to external constraints or surprises that might occur over the development phase. And it's a way to finally, ending up with a more robust list of requirements. So this is illustrated here on the graph drafted at the end of the co-design type 1 with the Athens pilot. So it shows the range of potential services at different time horizons for each user, which is here associated with one color. So finally, the objective and the principle of the co-design action toolkit take form in a specific process that is well codified to ensure the broad exploration I was just talking about, and avoid fixating on specific issues and solutions. So this is, of course, something that needs to be further experimented for the other co-design types. But what we can say for now is that the distinction between quick fit and resilient fit can probably be generalized to the other types, where quick fit actions would be to focus on finding one type of interaction with the ecosystem, a single list of requirements with one user, etc. Whereas resilient fit actions would be to focus on generating a range of alternatives for a better adaptation to future surprises. So if I go back to the parallel with the gardening activities, well, quick fit could be compared to a situation where the plant's roots are only located at the surface level. That is, the plant only grows if water is easily accessible. And for resilient fit, it would be a situation where the plant has an extended root network at different depth levels. So the plant is more resistant to various water conditions. So if we make the exercise for each type, for type 2, a quick fit could be finding a new relevant user to interact with. And resilient fit would be building relationships with a portfolio of relevant actors. For type 3, a quick fit would be building a technical infrastructure for an operational service, but for only one existing user. And resilient fit would be structuring the service offer for a range of users and building all required resources through different partnerships. And type 4, well, a quick fit would be just asking existing users what they would dream of and just realize what they ask for. And resilient fit would be to actually set up a kind of joint program for long-term co-exploration of new usages by identifying the different obstacles and efforts to be made. Of course, this still needs to be improved and validated through our next experimentations. Well, I'd also like to mention that the other work package of eShape can also feed the different co-design types by their different actions. So, for example, work package 4, that is led by ERSC, can help with its liaison activities, promoting eShape pilots to different entities of the EO ecosystem, and its user uptake approach with a taxonomy method. So it can support the type 2 and type 4 that are related to the exploration of existing and future users' ecosystem by initiating some contact points with these ecosystems. Another example is work package 3 through the identification of the different available EO infrastructures that can be helpful for the pilot in type 3 if they want to move towards operational services. Okay, so we are reaching the end of this presentation, so I will now conclude. So we've seen that co-design objective is to grow an ecosystem of efficient service designers, and to do so, it must include both a diagnostic toolkit and an action toolkit. So a diagnostic toolkit to identify blocking points in the ecosystem's growth, and an action toolkit to unlock blocking points, with a distinction to be made between quick fit and resilient fit actions. And second result is actually to confirm the relevance of the diagnostic toolkit through the analysis of the pilots. So we have seen that indeed co-design type 1 was not the only relevant type for the pilots. Okay, so now what are the perspectives for the future? So first, regarding practical perspectives, so in eShape we are progressively building a co-design process, but on the long term, the objective would be to put in place an engineering of the co-design process that would benefit to the larger EO community. So this engineering will have to involve tools that we will further develop within eShape, and that will make more easily reusable as well. This engineering also involves the question of competencies. So the idea would be to train interested partners, beginning with pilot leaders, but possibly others. And finally, there is the question of the organization. So maybe a dedicated team of experts could be built to handle this co-design process within your geo or geo. So there are already advances that are going into this direction. So we have already initiated some interactions with the eShape pilots to reuse the eShape co-design in other projects they are involved in. And there is also the training part that should be developed through another program supported by CNES, and this is still under discussion. So finally, regarding the academics perspectives, there are also major research questions that are behind this co-design to grow an ecosystem. So here, the issue is not only to design a product or service, but to design something that is alive. So that's why I took the metaphor of the gardener, and obviously it brings about some new interesting perspectives and also new questions to be solved. So this is the end of the presentations. Thank you very much for your attention. So now we'll be happy to answer all your questions. Thank you.
Thanks a lot, Raphaelle. So I remind to anyone that you can use the live Q&A to So thanks a lot, Raphaelle, for this presentation. That was really interesting to see your progress in the co-design aspect. I think the attendees can have a lot of questions, and that can be raised in the live Q&A. But waiting for their question before they type it, I have a series of questions for you. If I can, it's a lot of people to type their question, but at least we can go to this one. So when you make all these, so I understood that you wish to develop a full toolbox for this design activity, this co-design activity. But one of the questions I have in mind is first, do you have the idea that anyone can use this type of co-design approach, or do we need a specific skill to be able to conduct this diagnosis phase and co-design action? You have to unmute first.
Yeah, thanks, Thierry, for the question. And actually, what I've tried to say in the conclusion was to say that we'll try to make the tools reusable as much as possible, but it will probably need to be complemented with some trainings as well. So I see it as two complementary things, having toolkits that are robust and kind of routinized toolkits, plus some training to complement it.
Okay.
Pascal, I don't know if you want to add something.
Yes, we have also to insist on the fact that already many pilots are quite good in co-design methods. We found many pilots that are already expert in type 1. And the things we wanted to do is to improve these competences, probably by improving the shift from quick fit to resilient fit. And this is where maybe additional competences might be useful.
Thanks. We have two questions on the chat about the first one is, will the toolkit allow people to learn about co-design? So you can see that on the timeline and on the big panel you have in front of you. Yes. So it's not the same window. But the first one is about the toolkit, and are we able through the will we be able through the toolkit to learn co-design? I think it's how to co-design and do co-design, or how do you define it? In fact, the question is more, what do you think there will be in the co-design toolkit? So I understood that there will be the diagnosis tool, and also the different type of action that can be conducted in the co-design action. But maybe you can say more about that.
Yeah, yeah, you're right. Well, actually a co-design toolkit could be described with several parts. So there are the different deliverables that we are writing to try to frame the overall approach and explain the approach and the model that is behind it. And in addition to that, as you said, well, there will be diagnostic toolkits plus action toolkits. And for the action toolkits, well, the form of it will be also the support presentation we use to organize the different co-design actions we experimented with the pilots, plus the reports that we wrote at the end of the workshop, so it can give some let's say practical experience as well of how the co-design action were carried out. Yeah, that's what I can say for now. Pascal, maybe you want to come?
Yes, for the moment, it's true. I see the question of Nicolas and Laurent. What we make available is all the materials that we used, including the patterns, all the presentations. It is not for the moment an organized training. Following the question of Laurent, we provide the material, but it's probably not self-supporting. And this is where, for the moment, we are ready to support personally, but the question of training is not really in place. What we propose is, first, we can do this with you as pilot or pilot participants. And in the near future, we could probably imagine some cross-fertilization between the co-design initiatives. So if one pilot participant would like to participate to a co-design initiative in another pilot, we could think about this. But the training process was not really in WP2 as such, and we are now thinking about having that in place.
Yeah, in addition, there are some capacity building activity that are going to be carried out in VP 4 and 5. And I think it's also where we will have the feedback
Absolutely.
And some additional information. Nicolas is asking about the fact that it can, do you think that at the end of the day, it can also be designed as a service, the co-design approach?
We could probably think about this, yeah.
Okay. And we have a nice feedback also coming from Evangelos Gerazopoulos about, which is not a question, that he'd like to thank both of you to leading them in the process. So it was really helpful with their existing stakeholder from a different perspective. And so they'll start meeting separately with them and doing much progress. So I think Raphaelle and Pascal, you will have some feedback on that about the health surveillance pilot.
Thank you, Evangelos.
Okay.
It was a pleasure to work with you, with all your team.
Also, just to see if I wouldn't understood, how long does it take usually to make a good diagnosis about one of these EO services?
Well, probably it took us a bit more time because it was the beginning, and then we set up the process during the process. But what we did was to have, well, a first phase of representing the pilot and then asking some questions through Confluence with the pilot, and then having an analyze on our own, and then having a telco of 1 hour and a half with the pilot to validate or to change the analysis we've made of the pilot and to have the updates as well. So there is at least this 1 hour and a half telco one-to-one session with the pilot. And before that, there is also, well, the preparation work, which was quite long because of it was the beginning, and that's where we started to build the model as well. So maybe we could actually have a better vision on that doing the onboarding, doing the exercise on the onboarding pilots.
Yeah, that will be of interest, I think.
Your questions more precisely then.
Okay, thanks a lot. So I think we don't have any additional question for the moment. So I think we can thank you a lot for the presentation and for answering to the different questions. And we can jump on the second presentation from Marie-Françoise, which is here, related to the status and challenge of the European EO infrastructure. Thank you, Pascal and Raphaelle, and Marie-Françoise, the floor is yours.
Thank you, Thierry. I will run a video if the technology allows me to do so. So just a minute. Sure. Voidrot, I work with the Open Geospatial Consortium, and I am involved in eShape as lead for the work package re-implementation. I will present the status and challenges of the Earth observation infrastructures based on the lessons learned from the first year of eShape. So as mentioned before, eShape is gathering 55 partners, 7 showcases, 27 and soon more pilots, and it has a 4-year grant. 55 partners is a super panel to really identify where is the Earth observation community right now. And we will get a lot of return on experience from the pilots, and we have a clear target, but of course we will communicate before, and this is typically what we are doing today. Considering the implementation structure and timeline, we began with the task of an initial assessment because each of the pilots were building on previous works, and we needed to know exactly what was developed already at the beginning of the project and what were the plans during the projects to be able to monitor the progress. Then we have implemented a sprint 1 with goals which are aligned with the KPIs of the project. Then sprint 1 assessment, sprint 2 in 2021, an assessment of the sprint 2, and during all the project lifetime, we will build an eShape development guide. So where we are today, it's here. Over. The sprint 1 is finishing, and the assessment is ongoing, and we will soon prepare the sprint 2. And the development guide is ongoing during all the projects, I said before. So considering the initial assessment findings, these are the expectations that the pilots have expressed to the eShape pilots. So first, they expect from the pilots to more knowledge on the platforms, on standards or best practices, how to access the data, and then some marketing and development, co-design, some questions for the other work packages, and some knowledge on the innovation technology, but we can see that the bigger weight here is on the knowledge on the platforms and the standards or best practices. So what we have done is that we have organized all these questions and all these issues on a conceptual workflow with a logic approach. The users want to access the data or want to run the pilots, so they can run the pilots via Jupyter Notebook or access via a graphical user interface. And they might wish to discover data or to learn about the data assets. And they can wish to access the data machine to machine. And here we have all the questions and the issues about the platforms. So by considering the platforms, they wanted to have a comparative analysis of the platforms and cloud services. And typically the offerings including the provided tools, the services, the authentication, processing policies, capacities. So we have a full bunch here of questions about the platforms that the pilots expected us to address. What we have done is that these issues and this conceptual workflow has been used to build the template of the final eShape development guide. Because if these issues are of interest for the Earth observation eShape pilot, they are of interest for the whole community. This is where I say that the 55 partners represent the focus of interest of all the community. And specifically on the platforms here, we began to build a catalog of the Earth observation resources. So which platforms are we talking about? It's the platforms which are in the focus of eShape. So the platforms that have been mentioned as used or considered by one of the 27 pilots. And out of that, we need to build a framework that will help assess and understand which is the focus of each of the pilots, which are its unique values, and which are its capacities. We know that we do not cover all the European platforms. We will see later if this framework can be reused and extended, and that there are other references which are of interest for the community like Amazon or Google, but we are focusing right now on the platforms that are considered by the pilots. When we ask the pilots which are the platforms you use or plan to use, they have mentioned more than 40 platforms, which is, I think, a lot, but they've mixed very different things. They've mixed a portal that has a service, platform as a service. So this is why I represent that like a messy ball. And of course, we find all the DS and some thematic exploitation platforms, but not all. For instance, we have the food security, geohazards, hydrology, urban, but we don't have forestry, coastal, and polar so far, meaning that we already know that we are not covering all the European platforms, and some collaborative ground segments, like CODI. So how to characterize these resources? They have some attributes that can help distinguish the capacities. For instance, some mathematics, specialized or generalist. Considering the coverage focus, they can be regional or global. The data types, some are specific on satellite, for instance, or citizen science. Some are heterogeneous. The user focus, some are dedicated to research, or do they address also on duty and business. Considering the cloud services types and the technical layers they address, some are portals, some are data hubs or data as a service, and some are platform as a service, infrastructure as a service, etc. And considering the archive depths, what is the online, the data which is online, this is also something that can distinguish them, as the storage is super expensive, and the governance and the business model. So this already helps to sort out a little bit these 40 and more platforms, because the thematic here, you will find, for instance, the tabs in the thematic platforms, and the DS into the generalist platforms. We have the Landsense, which is dedicated to citizen science, Actress for research in situ, Copernicus Open Access Hub for satellite, and then some regional. But of course, we still have here a full list of generalist platforms that look alike, and we have to deepen the services they provide to distinguish them a little bit more. So considering the cloud services, these are typical graphics we can find on the internet. This is when you make an internal development, you outsource the network. When you outsource the infrastructure, this is what we call a IaaS, infrastructure as a service. Platform as a service, when you rely on the external provider to install the operating system and some basic software. And software as a service when everything is outsourced. And here you have data as a service, which is a specific architecture, which is very common in our landscape. So if we try to here put some stickers on which are the ones which are platform as a service, I have identified in green the ones which are sharing ELIP platform, Teradway platform as a common background infrastructure, and in yellow here the DS. And then you can see that we already in some groups of platforms which look alike, we begin to distinguish some different capacities here. So this is an example of characterization of the platforms which share Teradway ELIP as a foundation. And you can see that here we have two thematic platforms, which are for geohazards and hydro. They all make platform as a service based on ELIP. And NextGeos is global. It's general thematic and it's global. It's also richer in diversity of data. And ELIP is a platform as a service focusing on satellite, but of course, it is also the underlying technology for the three different platforms. So considering the DES, they look alike very much, and this is normal because they start with the same grant, and so they had the same goal after 18 months. And they are now distinguishing their offer. So what we are doing is a systematic review for each layer on commonality specificities to identify the unique values and the levels of interoperability. The goal is not to push any competition, but to identify the best fit for use. This work has already encouraged the pilots to consider the DES, some pilots which did not consider the DES into the initial assessment. And of course, considering the costs, because we don't have to only to compare the technology, but also the cost. And right now they are very difficult to compare because the pricing lists are very different. So we might use some ESHE pilots as real scenarios, and we need the pilots to be able to draft specification to assess the costs through the different DES. So we review for each of the layers. So this is the review for the data layer, but of course we will go into all the different cloud services. We have some commonalities, which are the Sentinel and Copernicus services, and this is normal because this was a part of the grant document. But then they have specificities, and these begin to distinguish the DES. We have to be careful because there is flexibility for the user to add more data maybe. So this gives a first image, but we have to go deeper, and the flexibility is also a capacity which is linked to the DES that has to be assessed. So we went through all the different layers. The previous one was on the data catalog, but we have also the data discovery services. We have the data access, what is online and offline catalogs, the libraries and toolbox, the environments, and for each of the layers, we have to identify the commonality, specificities, and the flexibility. So what we have seen, in fact, we have let the pilots select the platform and begin the dialogue with the DES. And what we have seen is that they most of the time have the same question which come back. And which are these questions? It's about the user interaction, how to better interact with the user on the web, how is the registration process, how easy is it, how is the authentication, considering the data, how to handle specific needs. This is a very frequent question. What if some data is missing for a pilot? What is the policy to enrich the data catalog? How can external data in situ, commercially available, proprietary, be accessed, be included into the processing scheme? Should we make directed load versus remote access? Is the data quality checked? And data search, how efficient is it? Considering the cloud technologies, most of the platforms express a need of support or capacity development to prepare the pilots to be scalable, to prepare the pilots to be deployable, so about Docker, Kubernetes, etc. On cloud technologies to specify the technical needs to the platform providers. And then they also, considering the assessment of the platform, they need to know about the capacity to handle full blockage mechanism from GeoDAB, which are the provided tools and services, and what are the processing policies. Considering the results visibility, what if some pilot wants to publish data or services into the marketplace? Is it open to all? If open, what is the process to publish data, to publish an application? Because I consider that the application look like data, they should be the same. It's just the interaction which is different. And then, of course, cost. We always have questions about the cost. Why? Because this community is used historically to use in-house infrastructure. So they don't have a specific budget to pay these resources. And so this is why right now it is that in the process to outsource their infrastructure. And so they need to, I think, implement the budgets and the process. Then what is the service 724, which level of SLA is available, considering the sustainability, which are the risks with the platform and the benefits to move from another platform, and which are the interoperability arrangements which are offered, and what are the selection criteria. So right now we have 15 e-shape pilots which are considering to use a DES or a platform as a service other than a DES. We have seen that we have others into the landscape. And what we plan to do is to consolidate and refine this first snapshot with the support from the partners. And I hope we'll trigger that this afternoon intensively via regular dialogue and common works with the platform providers. Also via, of course, the pilot's implementation, and consolidate the analysis framework in terms of metadata about each platform, the thematic coverage focus, and so on. Are this enough to distinguish the platform? Should we go further? Collect return on experience from the e-shape pilot's implementation, and maybe we will see if we can work on some interoperability and standards to go towards a European system of systems. And the level of interoperability should be mainly about authentication and authorization, the catalog services, the imagery and data exchange services, and the processing services. Thank you for your attention, and I hope this was of interest for you, and I am waiting for your questions.
Thank you, Marie-Françoise, for this interesting presentation, and that gives you a flavor of also the following of your presentation tomorrow, this afternoon and tomorrow. So, as we are in the same configuration than previously, you can ask all your questions through the live Q&A. Do not hesitate to do so. I think, waiting for the question, that your presentation gives also a nice overview of what we have in front of us. And it seems that it's sometimes difficult to find the path through all the different type of solutions that are available. Do you have any recommendation, insight in terms of using one or another solution? Or is it really a case-to-case solution that we should have? Or what kind of generic recommendation you can stress from your experience?
So right now, my approach is not to try to rank the platforms and say this one is the best and you have to go to this one. It is not at all the approach I am having here. I'm trying, my understanding is that we don't have big stakeholders like Google and Amazon in the US. So, but we have a broad diversity of platforms, and each of them brings some assets. I hope so. This is my position at the moment. We just have to identify the assets and to take the best of all these resources. The problem is that we have so many right now that the users are a little bit lost. So this is why I try to make this framework to characterize the platforms, to help them go more directly to deepen what they really are interested in terms of thematic, in terms of cloud services, and so they can focus on and look on the assets of each of these platforms and make their selection. But the selection criteria is something I still want to work on. To learn from the pilots that have already selected platforms and try to see if we can get some interesting lessons learned from that. So not only I went to this platform because it's done by the company I work with daily, but identify which has made them really go towards this platform.
Okay. Okay, thank you for your answer. We have a first question from Miko that said, do you think that the WCAO Harmonized Data Access API could be adopted by other PAAS provider? Which is very focused and technical.
Yes, this is it. It's very technical, and I did not go into the technology completely of this API, but based on what I heard, probably yes. And well, it has to be deepened. I think that at some point ECMWF was considering to offer it for some hackathon with OGC and so on. So it has to be deepened. But I trust ECMWF to have done a very good API.
Okay. And we have also a question from Gilberto Camara about do the JAS store all Sentinel data? I tried to assess Sentinel-2 data in the different JASs and found a lot of missing data. So it's also an expertise on how this and also on the frame of the archive that came from the different JAS. Do you have some insight about that?
So I think that the target of the DS was to offer all the Sentinel data, but I know that each of the DS offer a different depth online. They offer a service to bring from the archive to the online based on a specific request, but they have a certain depth in line. My feeling is that, well, at the moment, most of the DS, as far as I know, because this changes regularly. So, you know, I have to review the assessment regularly. But as far as I know, some DS have a depth of 3 months, 6 months, or a bit more. Only one DS is having a differentiation based on the geographical area, and they put more data online over Europe than over the full globe. I think that with the maturity, when the DS will get the analytics from the real uses from the users, they will probably refine this strategy, putting online the most used data and not only one size fit all depth of data. This is my feeling. This is the direction we should go. So this is probably something where there will be some trade-off in the future that will evolve.
Okay, thank you. We had also a question from Nicolas Fichot about how straightforward is it to engage with platform with a complementary, what level of expertise is required, and can the pilot be supported during their engagement with the platform? So 3 questions in one.
So this is something I will introduce this afternoon into the breakout and tomorrow into the process.
So you are not going to tease.
No, but we have worked on creating this process to interact with the pilots to make sure that we had all the tools to involve and engage with the 55 partners. This is huge, I mean, and going at the same time very sometimes very deep into the technical details or the implementation or the goals of the pilots, and sometimes very high to have this synthesis capacity to build the E-shape layer. So in fact, we have focused on this process, and now I think we are ready to really work on the interface between the E-shape project and the partners. And this is the topic of the breakout this afternoon. So I'm not giving the content because we will have several presentations from the platforms provider on this topic. But this is a nice teaser. So, well, the idea is that what we have observed already, my feeling is that the Earth observation community is not so familiar with the cloud technologies. The data scientists need to have many different skills, and the EO community, which is already a niche between the geospatial community, masters already a lot of IT technologies like mathematical models, statistics, remote sensing, but not so much the cloud technologies. And this is where we really have to plug the wagons. We have to teach the pilots to be able to talk with the cloud providers, and we have to discuss with the platform and cloud providers how to better engage with the pilots. And this will be the topic of the breakout and the future works.
Thank you. So Gilberto Camara comment on his previous question, saying that all the S2 data can be found in AWS. in Amazon. So he had also a question on about, I think it's a general question, or is it specific to eShape? That I don't know. On how many EO applications are ready to be packaged as services. From his own experience of the Geo work program, there are a few applications that are service ready.
Yeah. So tomorrow I will. I have shown already. This knowledge, the templates on how I want to capture the knowledge with the different activities you have to run when you develop a Earth observation application. And tomorrow I will make just a zoom on the last one, which is operational activities, because I wanted to explain which type of knowledge I am capturing. And you will see that, yes, I think that we still have a lot to work to get to a full maturity, to be able to have a very reliable systems with good monitoring, well, there is still work to do. And also I will detail this chapter because this is the target and the goal for our pilots, isn't it?
Mm-hmm. Okay, so you tease the next one, so that's good also. So Marion Oudayer asked if there is a selection flow considered to help the selection of the platform depending on the pilot needs. I think it's really implementation questions and how we can help them on this process.
Yes,
so we are building the experience, I know.
Yes.
But maybe you can complement.
Right now, I am not at this level right now. I try to identify, for instance, the platforms which are really focusing on researchers or a certain type of data. I'm narrowing the list of platforms to deepen. I'm trying to build a process to select, but the selection at the end is done by the pilot. And this is something which was important from the beginning, to let the freedom to the pilot to select its platform, because this is the warranty that the eShape project will onboard as many platforms as possible. If I was fan of a certain type of platform, I would completely lose the richness of eShape, which is given by these 55 partners and 27 pilots.
So this means, in essence, we can give some recommendation, but they have to do their own choice.
Yeah, exactly.
Okay, so that was also the direction of the question from Vasileios. He said that for many of the service developers, it's rather hard to assess which is the best DIAS option, even with the consolidated information on DIAS offers that you provide. Usually we need to play around a bit with each platform, and I think it is a message is given to all the DIAS, and some of them are participating or will participate this afternoon. So it will be really useful to have some limited access, at least 7 days or maybe more, to play with each DIAS. And he is asking if there is something that could be done along those lines, and if the implementation activity we had in eShape can help in this direction. And partly the answer is that we are working on a concept paper to go on that direction for all the DIAS at the level of the project itself. But you have also your own expertise on that to answer to the question.
Yeah, several DIAS offer some free assessment and access to the platform, but yes, this is exactly the topic of the partnership we are building between the project, and we try to build with the partners, is to discuss some conditions that would allow the pilots and the partners to go further into their own assessment, because the knowledge we want to capture and to bring is not theoretical, is not the assessment I'm trying to do via the web. It's really what comes back from the pilots. And so it would be great if the pilots could assess several DS. Yes.
Yeah, that will be the best in terms of evaluation, I think. So Miko, I have another question about data cube and models. Did you consider data as a service for model data? And these are data cube that will need to work well together with the EO data cube and platform AAS.
I did not assess that, but for sure, when it is a little bit ambiguous because some of the Copernicus data, as a matter of fact, are numerical model. They are not Earth observation per se. They are the output of models, the one from ECMWF and Mercator. And for sure, there are new products that can be made by the fusion of modeling and satellite or Earth observation. This is done by the Met Services. So yes, we should have some capacities to make available all these data easily to allow the data fusion over different types of data, including in situ, including citizen science, whichever. Not only satellite data. What I mean is that very often people consider Earth observation is satellite.
Yeah, I used to define it including the in situ and the models.
Yeah, so this is it. So in situ comes just before, so people accept that in situ is Earth observation, no problem. Numerical model, it's not so clear, but then citizen science, all the sensor on the web and so on, this is coming and this will be a lot of data. And all the results of data fusion themselves will be, I think, Earth observation data. It's like numerical model. It's fusion data.
Mm-hmm. I am fully agreeing with you. That was my experience about data fusion years ago. Okay, I think we made it. We have all the questions around that. If there is no more question, and I think there is no more, can wait for a few seconds. But I think it's a full set of questions we had. I think we will close the session maybe in advance, but it will let a bit of more time for the live session. So I would like to thank all the presenters for this participation. Sorry, I need to drink a bit of water to have a smooth language. And we will see you first on the live session for half an hour now with a new live session, and hopefully back at 2 o'clock to see the next breakout session. We have two in front of us, one dedicated to the platform and one dedicated to the new project, New Edge 2020 project, and we made an exchange around that. So it's not the onboarded pilot, it's the project related to Geo and Eurogeo and Earth observation in the last call from the Edge 2020 project, and we will start an exchange with them and see how we can collaborate together. So you have a lot of well done. Thank you. Great session to all of you. Thanks a lot, and see you at 2 p.m. the latest, but in the live session before. Thank you very much.
Thank you, Mr. Chairman. Bye.
Bye.